Hi my schoolers, my name is Abiola and this is my school YouTube channel. What we'll be doing right there is we'll be solving topic by topic in the subject mathematics. Alright, so we've divided these topics into various units. Okay, so for unit 1, which is number numeration, we'll be solving the topic number basis. So all you just need to do is to stay with me as we move to our solution platform to solve the topic number basis. So join me as we move on. For the first unit, we have topics that have been compressed into it. That's the first unit, which is number and numeration. You know, we talked about sets, that's sets here. We talk about sorts. We talk about indices and logarithm. We talk about variations. We talk about number basis as well with some other topics. So at first, we are considering number basis in the first unit, number and numeration, the subject mathematics. So let's just have the hierarchy this way. Mathematics, the first unit, number and numeration. In the first unit, we are looking at the topic number basis. So let's get introduced to number basis properly. The introduction. What is a number base? You are talking about a counting system that uses a notation to tell you or to represent digits. Okay, this is just what I mean in simple terms. When I talk about base 2, that tells you there are two different notations which include 0 and 1. When I say base 3, that tells you about three different notations: 0, 1, 2, and 0, 1, and 2. Okay, that tells us three different notations. When I say base 10, that tells us there are 10 different notations. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you can notice a particular trend that for every base that we're working in, there is the highest number is -1 less than the base. Okay, so like for instance, you can see base 3. You can see that the highest number is -1 less than the base. So 3 minus 1, that is 2. 2 minus 1, that is 1. Okay, if we're working in base 5, that tells you that the highest number will be 4. Now let's take this for instance. If we're working in base 7, what will be the highest number or highest notation? Of course, that will be 6. So that is just the brief introduction we have when it comes to number bases. I can have this as well. You know, in number base, this is how, if I have this compilation, all right. Okay, this is how we read it, not 4,321. We don't need to do that in number basis. We just say 4321 base 8. Okay, or we can have this. This is 5037, whatever base I want to use. Let me say base 9. Okay, so you can see all of this being put together. Then there are some recommendations that to avoid confusion, because this is the bases, they are written as subscripts. You can see underneath. This is superscripts. This is superscript. Okay, this is subscript. So you can see the bases are written as subscript. So some recommend that instead of you using digits to represent the basis to avoid confusion with the value you are given, you can use words instead. So I can have this as 4321 base 8 and this as 5037 base 9. Okay, just to avoid mix-up. So that is a very good introduction to number bases. So let's go into the various number bases that we have. I've just mentioned them. We have base 2, we have base 3, base 4, 5, 6, 7, 8, and what have you. So base 2, you can refer to base 2 as your binary system, okay? Base 2, that is binary. All right, your base 8, that is your octal. Your base 10, that is your decimal, or you can use or you can call it the denary. Then base 16, we have your hexadecimal. Okay, so, and of course, we can pull a linkage between base 2, base 8, and base 10. Okay, so that's where we look at the 4 bits, the 3 bits, complements, but we're not going there right now. Okay, so you can see your base 2, your base 8, your base 10, base 16. Of course, there are other bases, but these are the important ones. And I just want us to know this. The normal addition, subtraction, division, multiplication that we do them in base 10. That is why when you are trying to do some simple takeaway, you realize that by the time you are borrowing from the next neighbor, okay, you see that whatever thing you are adding will be added by 10. So your natural base we've been working on or working with so far is base 10. So join me as we move to the next part of this topic, number bases. We are looking at the different operations that are involved or that are being engaged in number bases. So those operations are just like your addition, your subtraction, your multiplication, and your division. It's important to know that you can just carry these operations out just the way you used to do your regular division, multiplication, and addition. However, there are just some simple rules that you have to take note of. Okay, so when it comes to operating in addition or subtraction or multiplication, let me take for instance subtraction. If I'm asked to subtract in base 2, for instance, I have something like this. Okay. All right, so in this case, I can decide to use the regular way to work around this, right? 1 minus 1, that is 0. 1 minus 0, that is 1. 1 minus 1, that is 0. Okay, I can decide to do it this way, or I can decide to use what we know as the 1 complement and the 2 complement. Okay, 1 complement and the 2 complement. I'm going to be sharing that with you in the next video. That is where we have the full compilation. Okay, so, or I can decide to first convert this to their various representation or various values in base 10, this to base 10, then I will now do the normal subtraction, then bring the answer back to the base 2 that we are working in. Don't worry, in the next video, I will provide you with more step-by-step explanation. So we can decide to use this. If we are working in base 10, we can use another method. We can use in regular subtraction or regular addition. But if you are working on subtraction in base 10, instead of using the 1 complement and the 2 complements, you'll be using the 9 complements and the 10 complement method. Don't worry, I will share that with you. Okay, so then we have conversion from one base to the other. So like for instance, I want to convert from, let's say I want to convert this 465 base 7 to base 10. Okay, so I can use different method. I can use the normal expansion method, or you can call it the power expansion. All right, so this is what I mean. That will just be 4 times 7 raised to power 2 plus 6 times 7 raised to power 1 plus 5 times 7 raised to power 0. I know you may wonder how we have all these powers. It's just very easy. Just introduce your knowledge of place values. Okay, this is units, tens, and hundred. So remember that this is 100. 100 means 10 raised to power 2, isn't it? That is the 2 we have here. Tens means 10 raised to power 1, then units 10 raised to power 0. Very easy, right? So if I have something like this, probably I have something like this, 501768. So let me say base 9. Okay, you can see I'm very cautious about the base I'm introducing. See, the highest we can have should be 1 lesser than the base system we are using. Okay, so you can see this. So let's now identify this is units, tens, 100, right? 1000. This is 10,000, and this is 100,000. So you know your unit is 10 raised to power 0, right? Your tens is 10 raised to power 1, 100 10 raised to power 2, this 10 raised to power 3, this 10 raised to power 4, and this 10 raised to power 5. So if I'm introducing or using the expansion method, what I will just do, starting with the first one, 5 times 9 raised to power 5, right? Then this plus 0 times 9 raised to power 4, just like that. Okay, so that is where we got all these powers that are being introduced to work on this sets of operations. So that is what we'll be doing in the number system. So converting from a particular base to base 10. Then what about if you are moving from base 10 back to another base? What do you do? It's very easy, trust me. So if I have something like this, probably 44 in base 10. Remember I said the natural base we are working with is base 10. So even if I don't put base 10, just know that this is indicating base 10. So convert 44 to, let's say, base 2. So I can use this, the division method, the successive division, okay, if you like. All right, something like this. So I have 44 here, I have 2. 2 in 44, that is 22, remainder 0. 2 in 22, 11, remainder 0. 2 in 11, I have 5, remainder 1. 2 in 5, I have 2, remainder 1. 2 in 2, I have 1, remainder 0. 2 in 1, 0, remainder 1. Okay, you must make sure that your last quotient is 0. So if I try to power up like this, if I have my compilation, that will be 1, 0, 1, 1, 0, 0. So that will be 1, 0, 1, 1, 0, 0. So that is it in base 10. So you can see that we have lots of wonderful things to look at. As well, converting from a particular base to base 10, then to another base. That's what we'll be looking into as well. So I don't want you to miss out. All you just need to do is to come to the My School website by clicking on the link. We have provided a special package for you because you'll be subscribing for this wonderful package. So you don't want to miss out. So join me as you click the link and get the best of My School YouTube service.